Boys and girls, how are you? I am so glad to meet you by this lesson, which is very important. A great contribution was done by Ernest Rutherford for the enhancement of chemistry and its experimentation. I am so glad and very happy to present to you Rutherford's atomic model. For this one, we want to think about contextual background of this topic. Actually, we know that Dalton assumed that atom is indivisible and the smallest particle which can participate in a chemical reaction. It was proved to be wrong. Then Thomson came to introduce another concept, that is, atom is divisible, but it has a small sphere, electrons are embedded, entire positive charge is spread over the atom. But after 1903 to 1911, there were some experiments done by Ernest Rutherford. He came from New Zealand. He was the student of J.J. Thomson. But Rutherford, a great scientist, it is no hesitation to say that, to me especially. He is my favorite scientist. While he was doing one experiment that is called alpha particle scattering experiment, he gave out so many postulations, which we called as thoughts. That is by the result of alpha scattering experiment. We never forget it. I want to explain this alpha scattering experiment first. Then after, I want to go to explain the salient features of Rutherford's atomic model. Point number one, alpha particle scattering experiment means, first of all, alpha particle scattering experiment which contains gold thin foil. Approximately its thickness is 100 nanometers. And it has bombarded with high energy positively charged particle, which is called double ionized helium. That's we can call it as He plus 2 ion. Charge is plus 2, mass is 4 units. And the gold foil had arranged with a circular fluorescent zinc sulfide screen, which is around the gold foil. What is the purpose of the gold zinc sulfide screen? Whenever an alpha particle struck the screen, a tiny flash of the light was produced at that point. So zinc sulfide screen, which helps to detect the flash, simply the flash of light. Rutherford knew that alpha particles had enough energy to pass through the gold foil atom. He did that experiment. Based on that experiment, he found some result. Number one, most of the alpha particles are passed through the gold foil and not deflected. Simply, we can say these alpha particles are undeflected. That is the profound statement at the time it was given to us. Second, a small fraction of alpha particles was deflected by small angles. That means some of the alpha particles shows their behavior just by deflecting with a small angle. Third point, a very few alpha particles which bounce back. That means deflected by nearly 180-degree angle. Three kinds. Number one is, most of the alpha particles are undeflected. Second one is, some of the alpha particles were deflected with small angles. Very few alpha particles are deflected with 180-degree angle. From these three observations, was led to explain Rutherford's atomic model. Features are like this. Number one, atom consists of a heavy and positively charged part at its center called nucleus. Simply we can say atom is spherical mostly hollow. This observation, this concept, which is contrary to the Thomson atomic model. So mostly hollow. Actually, Thomson said entire atom is spread over with charged particles, positive and negative. But this is wrongly proved by Rutherford. So atom is mostly hollow, and the central part of the atom is made with positive charged particle that is called nucleus. Nucleus was invented by Rutherford. The diameter of the nucleus is 10 to the power of minus 14 meter. The entire mass of the atom resides in its nucleus and is equal to the sum of the masses of proton and neutrons, since the mass of electron is negligible. Dear students, nucleus contains nucleon. Nucleons means combination of proton and neutron. Electrons are not present in nucleus. So what about the position of electron? Electrons are continuously revolving around the nucleus in their specified path, which is called orbit. So electrons are revolving around the nucleus like the planets revolve around the sun. This is the point we must notice. So when we compare with the size of nucleus is less than size of atom. So size of atom is greater than size of the nucleus. Size of atom is measured in angstroms. Size of nucleus is measured in Fermi. Dear students, from these 5 postulations, the contribution of Rutherford through this alpha scattering experiment, it has given a revolutionary thought and correct explanation. That means to contradict the thoughts of his guru, J.J. Thomson, and he corrected the statements of Thomson, and he explained the real statements. This is really this experiment, this model, which enunciated and experimented and established one of the finest models in the atomic models. Children, thank you all. Please go through this lesson. I hope you're all thinking about this one. Please use your sense and thought process in order to get this subject. Thank you, children. Have a nice day. God bless you.